Now let's look at Hamiltonian circuits. Our Euler paths and our Euler circuits had to cover every edge. And remember, with a circuit, it had to start at the same vertex and end at the same vertex, whereas a path just had to cover every edge. A Hamiltonian circuit and path, the Hamiltonian path visits every vertex once, but doesn't repeat any of those vertices. But it doesn't have to start or end at the same vertex, whereas a Hamiltonian circuit has to go to every single vertex only once with no repeats, but then returns back to the same vertex. And this is not named after Alexander Hamilton like we saw with apportionment. This is named after William Rowan Hamilton, who studied graph theory way back in the 1800s. All right, so this Hamiltonian path, let's think of it like a truck driver. He has to go to certain cities to drop off things, but the path that he takes doesn't necessarily matter as far as edges is concerned. He can take any road he wants to the city, but he has to visit every single vertice, every city. All right, so let's take a look at an example of finding a Hamiltonian path and a Hamiltonian circuit. So let's look at these in number 17 here, and let's see if we can find a Hamiltonian circuit. All right, so I am again going to label my vertices just so that we can tell what our circuit is here in this first one. Now remember, I have to visit every vertice and then return to the same vertice. I don't have to visit every edge. So let's start at A, and I'll go to B, and then let's go to C, and I'll go to D, or rather E. So I'm going A, B, C, E, D, and then notice I've already got a problem, because now if I go up to C, I will have visited C twice, and I'm not allowed to visit C twice. So this is not going to work. All right, so I'm going to erase. Instead of starting with A, I'm going to start with my problem child C. Even if we start with C, let's just keep, well, I could go there, but boom, I'm back to C again. I've visited C twice. In fact, no matter what I try, in order to get to the others, I have to cross through C. This does not have a Hamiltonian circuit. All right, so the answer here is no. This one does not have a Hamiltonian circuit. So unlike Euler circuits, there's not a nice rule to tell us if there's a Hamiltonian circuit. We just have to play until we either find one or realize there just can't be one. Okay, so let's look at our second one here. Again, I'll label them. If we find a circuit, we'll go ahead and write it down. So remember, we don't have to visit all of these edges. We just have to visit every single one of these vertices. So I could go, let's see, I could go there, I could go there, 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 and back to A. There's a Hamiltonian circuit. I have visited every vertice just once. So let's notice we went A to D, and then from there, we drove to B, and then we drove to F, and then to C, and then to E, and then we returned to our starting point A. So we do have a Hamiltonian circuit in there, and we could find another one. There's probably plenty of them in there. All right, now let's look at this next one. All right, so again, I'll label each of these vertices. We'll just pretend they're different cities that we're going to drive to and see if we can return to our starting point without going to one of these twice. So let's see. Let's start at A. If we go to B, let's go to E, F, G, D. All right, now I've got a problem. I try to go to C, but then I've got to return to B. So doesn't look like we can get one, but let's try again. We can try from another starting point for that matter. We could try from our problem child C. Oops, I really didn't mean to get rid of all of those. So let's start with C just to see if we can find a circuit from C. So let's see, C to A to B, E, F, G, and then we have a problem of returning to D here. So really, no matter what, because that C is kind of a problem, kind of in the same way that this C was over here, we can't find a circuit. So this one is no. Again, with Hamiltonian circuits, we have to play and see if it seems to be possible or not. And this one doesn't seem to be possible.